we're gonna look at some more examples of graphing systems of equations. We're gonna look at y equals 2x plus 5 and y equals 2x minus 3. And the directions are solve the system of equation by graphing. It's at the top of the page. Okay, so again, the first thing we do is graph both lines. So we have y equals 2x plus 5. We identify our m, which is our slope, is 2. Our b, which is our y-intercept, is 5. We start always at the b, so I'm going to start at 5. My m, we have to make a fraction, so remember we always put it over 1. And then the top number is the rise, the bottom is the run. So we go up 2, right 1. But we're going to say, okay, wait a second. If we do that, we're off our graph, and that doesn't happen. So if that happens, so if I get a slope and I count it and it's off my graph, we can go the complete opposite way. Okay, so we could go up to right 1, or we could go down 2, left 1. Down 2, left 1. Because if I do that and I draw this line, I'm still going to get the same line as if I went up to right 1. So you can always go in the complete opposite direction. Okay, and I'm going to do it one more time. Down 2, right 1. Another time, down 2, right 1. We want these lines to be as exact as possible. So the more points you plot, the better. Okay. So if it goes off the graph, then go in the complete opposite direction, okay? And the reason is we could say both of these are negative, and a negative divided by a negative is a positive, so they're the same value. All right, so that's my first line, this 2x plus 5. So label that line. The second line is y equals 2x minus 3, okay? So m is 2, b is -3. We start on the -3. Okay, so I make a point on the y-axis at -3. My slope is 2 over 1, so I'm going to go up to right 1. And I'm going to do it again, up to right 1. We can keep just counting the same slope to make the line up to right 1. Okay, we could also go from this point down to left 1. And what we're going to notice is, okay, these points do not ever intersect, and they run completely parallel. Okay, and the only time they're parallel is when the slope is the same. And that's the case. The slope is exactly the same. Okay? And so if you see that, the solution is no solution. And we can't really check it because there's no points to plug in. So the solution is no solution. Okay, so anytime you get parallel lines and check, make sure your slope is the same, then we say no solution. Okay, so I recommend you trying 3. Okay. Trying 3 for this problem, and pausing the video and then coming back and trying to see if you got the correct answer. Okay. So hopefully you pause and try to see if you could do this. If you did, for that first equation, m is 4, b is 3. So I'm going to go to 3 on the y-axis. My slope is 4 over 1, okay? And so I usually want to go up 4, right 1. I have a problem again. If I go up 4, I go off the graph. So I have to go completely opposite, which is down 4, left 1. Make sure you go completely opposite. So down 4, 1, 2, 3, 4, left 1. I'm going to do it again. 1, 2, 3, 4, left 1. And then I have my line. My second line is y equals negative x minus 2. Okay, so my b is negative 2. My m, we don't write it, but it is a negative 1 in front if we don't write it. So we're going to start. So this line is 4x plus 3. We're going to start at negative 2. Okay, we need to make it over 1 because we need a fraction. And then I'm going to go down 1, right 1. Down 1, right 1. Okay. But I want to hit my line, and I can't if I go this way. So I have to go again opposite. So I would go up 1, left 1. Okay, so we could say it is 1 over negative 1, because either way, if I divide these, I get the same number. So we're going to go up 1, right 1, and then we hit our line. Okay. And just if we count, we're more likely to get it exact. For the solution, we find that point. So this point, the x value is negative 1, okay, because it goes here. The y value is also negative 1. So my solution is negative 1, negative 1. And then we could do a quick check and plug it into both equations. So again, my first equation is y equals 4x plus 3. We have negative 1 equals 4 times negative 1 plus 3. 4 times 1 is negative 4 plus 3. Negative 1 equals negative 1. So we're good. The second equation is negative x minus 2. We have negative 1 equals negative of negative 1. We still have that negative sign. Our x is still negative. Remember, this is my x, this is my y. We have negative 1 equals, okay, a negative and a negative, that's a positive. And then 1 minus negative 2 is negative 1. Okay, and so that is how you do systems of equations when graphing when they're in y-intercept form.